Dear participants, I'm very happy to welcome you all and today's speaker, Mr. Colins Kibet from Kenya. It is proud privilege to me to introduce today's speaker, Colin. I came into contact with him with one of my friends from Kenya, Dr. Isaac. Today, Colin sir is going to talk about image enhancement and transformations, and especially he will focus on radiometric enhancements. He is one of the leading personalities in the field of geospatial technology from Kenya. He has developed the skills and he has great interest in the field of geospatial technology, digital image processing, visualization, and storage of geospatial data. Till today, he has been in association with various institutions from Kenya. He is presently in association with the Technical University of Kenya. Before that, he was working in Global Link Technology Training Center at Kenya, New York High School, Kenya, Stewart Primary School, Kenya. It talks about his interest in the field and the versatile personality of Mr. Colin. Till today, he has published various research papers and he is working in the area of geospatial technology. With this brief introduction, I welcome Mr. Colin on the virtual platform of this international workshop on digital image processing. Mr. Colin sir, I welcome you on behalf of Department of Geography and IQC of Atlas Apre Pitre College, Devruk. I would like to talk about little bit about our institution. Our institution is one of the autonomous colleges in the Konkan region of Maharashtra in India. You will find that it may be only autonomous college from the rural area and hilly areas. We are working hard and you may find that uh, the situation and the background of the students, it may be like some of the African countries that this region is economically backward region of Maharashtra. And in this region, our institution, our parent institution is trying to provide a qualitative education to all the students from the region. And also some of the students are taking admission from other parts of Maharashtra in India. We facilitate education till PhD affiliated, and it is affiliated with University of Mumbai. You might be aware about Mumbai University. And we facilitate PhD in geography, PhD in chemistry, PhD in physics, Marathi, etc. It's all about our institution. On behalf of all the collaborating institutions, I welcome you on the virtual platform and I request you kindly proceed ahead. Thank you.
Thank you very much. Uh, and I'm very grateful for this opportunity that I've had to share with you, all of you, during this international workshop. So it's 4 p.m. here in Kenya, and I'm very sorry for confusing the time because I thought it was Kenyan time, and I'm really sorry for delaying all of you. And I'm going to just make it brief so that next time we'll do something better. So as you've heard, I'm speaking from Nairobi here in Kenya, and we are very happy and we honor your invitation. I'm speaking on behalf of the institution that is the Technical University of Kenya, one of the leading institutions here in Kenya in offering surveying and geospatial courses. So about our institution, maybe I can just talk about it briefly. We have 8 programs. The university trains on Bachelor of Science in Land Administration. We have Bachelor of Science in uh, Geospatial Information and Communication Technology. We also have Bachelor of Technology in Geoinformation Technology, Bachelor of Technology in Surveying Technology, and diploma programs in surveying technology and geoinformation technology. So all those courses are correlated with specific specialization fields. So I'm very interested in the digital image and processing field of geospatial science, and I was assigned to take a topic on that was radiometric enhancement, and I'm just going to go through the slides before we check on 1, 2, 3 of the practicals. So allow me to share my screen, Daktari.
Yes, please proceed.
Can you see my screen, please?
Yes, sir. Yes, sir. It is visible.
Okay, okay. So I'm going to briefly talk on radiometric enhancements, and so radiometric enhancement in the digital image processing it simply means the process of adjusting the brightness, contrast, and color balance of an image to improve its visual appearance, or also to highlight specific features of interest. So when it comes to radiometric enhancement, it can be accomplished via a variety of techniques. We have histogram equalization, contrast stretching, and color mapping. So one of the goals of these radiometric enhancements is to make an image more visually appealing and easier to interpret, but getting in mind that uh, the important features have to be preserved and also noise has to be minimized together with the distortion. So one of the techniques of radiometric enhancements is on contrast stretching. So when we talk of contrast stretching, which is also known as normalization, it's one of the techniques in radiometric enhancements that adjust the intensity levels of an image so that the minimum and maximum values are spread out to fill the entire range of possible intensity values. So the basic idea is to stretch the range of intensity values so that the darkest pixel in the image becomes black and the brightest pixel becomes white, with all other pixels proportionally distributed between black and white. So this makes the image appear more contrasty by bringing out details in both the highlights and the shadows. So we can check on one of the practicals, because in my case I used one of the images that was captured by drone of Nairobi city, and one of the images we're going to add it in ArcGIS and see how we normally process it. So I'm going to add a sample image of Nairobi city, and then we can process it. We can process it by contrast stretching method. So having this image, we have a sample TIFF image of Nairobi city, and when you add it to ArcGIS, you can see the contrast and the appearance of the image. So this one is Nairobi city here in Kenya, and it has several buildings, highways, and also we have some vegetation.
Hello,
Hello?
Colin sir.
Yes.
Yeah, we are unable to see the presentation or practical task you are completing on your screen. We are
Oh,
only seeing, observing the Google Meet screen up from your PC.
oh,
Oh,
okay. So
yeah, please,
let,
please do the necessary.
let me check. Okay.
There may be possibility that you might have shared window only. At that time, it may not be visible to us. If you could
Okay.
share entire screen, at that time it may be visible. Please do the
Okay.
needful.
Is it now visible? Okay.
You need to minimize the Google Meet and need to
Yes.
work on your window.
Okay.
Yeah.
Okay. So can you see the practical
Yes, yes,
part?
yes, yes, yes,
Yes,
yes.
sir.
Okay. So this one is a sample image of Nairobi city that was captured with by drone. So as you can see, we have several buildings, the highways, and some of the vegetations. So if we are to process this image by means of contrast stretching, then the technique we normally use is about going to the properties of the image, and then you check on the RGB composite. RGB composite. But before we go to RGB composites, we are talking of contrast stretching. So we use the stretched part. So the software I'm here using is the ArcMap that is available in ArcGIS, and you come and choose the bands you want to stretch. For example, we have band 1, we have band 2, band 3, 4, 5, and 6. So assuming we want to stretch band 1, then you can check on the band properties. We have the highest and the lowest. You can see it has a difference of about when you subtract that one, you see it has a very large, very small difference. So what you do is come on the color ramp and then you choose. But because we say the black will appear darker and the bright will be white, so we come and check on the histogram. And when you come on this part and apply, you can see at first the histogram is like diagonal, and when you make the applications, let's see the effect. When you apply, you can see there are some changes in the image. You can see Nairobi city image is now becoming darker with some white. It has some white spots. So the white spots is simply about maybe the image was taken during when there was large amount of light in those places. And you can see the bright spots can be seen as white, and the dark spots appear to be black. So we can adjust the histogram. So this one will now fall under the property of histogram equalization. Because we talk of histogram equalization being a technique in radiometric enhancements that adjust the brightness and contrast of an image by redistributing the intensity levels of the pixels to span the full range of possible values. So one of the basic ideas is to adjust the image so that the histogram, uh, which is a graphical representation of distribution of intensity levels in the image, is as flat as possible with equal number of pixels at each intensity level. So this one will make the image become more balanced by giving more emphasis to the less frequent intensities. So when it comes to the practical part, we go to the histogram. You can see it's appearing to be flat so that it can balance the intensity of features that are captured in the sample image. So assuming we keep adjusting this histogram, let's check, for example, we can adjust here to, we have to count out to be 2 and the count out to be 3, but so in that case we have count out as 241 and the count in is 150. So if we stretch our histogram or change it that way, you can see it's not flat now, and if we make the applications, it's going to affect our image in a given way. So as you can see, the image is becoming brighter. You can see we don't have the white spots now, but the white spots are now almost turning the same with the other spots. So if we keep on adjusting this histogram, we can stretch it further upwards there so that it becomes like a curve. Then we make the applications. Okay, let's stretch it a bit that way. You can see our image has been converted. You can see now that everything is turning brighter than it was. So to make this image now to look presentable or to show detailed features that were captured, that means we have to try as much as possible to flatten this histogram. And this is the process we talk of histogram equalization. So you see, the more we adjust it to move it upwards there, that means our features are not going to appear exactly as it should be in the ground. So you can see our image there has turned to be darker, Okay, now we move to the next thing. We talk of histogram matching. So in histogram matching, which is also known as histogram specification, so this is a technique in radiometric enhancement that adjusts the brightness and contrast of an image by modifying the intensity of the pixels to match a specified histogram or a target distribution of intensity levels. So the basic idea is to adjust the image so that the histogram of the image matches a predefined target histogram, which could be an histogram of reference image or a desired distribution of intensity levels. So histogram merging can be accomplished by applying a mathematical function to the intensity values of the pixel in an image. So the function maps the original intensity values to new values that are chosen to match the target histogram. The function is chosen based on the target histogram and current image histogram. The process is done by comparing the cumulative probability of target histogram and current image histogram and mapping the intensity values to match the cumulative probability of the target histogram. So this is normally very useful for images that need to match a specific visual appearance or need to be consistent with other images. For example, we talk of color correction, color consistency, and image registration. So in this process, it's just about the histograms. Initially, we were working with the band 1, so assuming we work with band 2 in this case. So band 2, and then we come and check our histogram. So you can see we're trying to make the equalization of the histogram so that it can provide a more specific or a detailed image here. So if we adjust this one, remember we are adjusting band 2 and not band 1. So let's check on the effects so that we'll uh, make the histogram equalization. So assuming we adjust it that way, in this case, we're going to make the applications, and you can see, so this one is now band 2. You can see the effect it has caused on the image. It's not like the other one. It has some slight differences. As you can see in this case, you can't easily tell the difference between some of the buildings and the vegetation, or some of the buildings and the bare lands. Okay, yeah, so that one is about histogram matching. Okay, we have again we have piecewise stretching. Piecewise stretching is one of the techniques in radiometric enhancements that adjust the brightness and contrast of an image by applying a different mathematical function to different regions of the image based on the intensity levels of the pixels. So the basic idea is to apply a stretching function to the regions of the image that have a low dynamic range, while in the same case preserving the regions that have high dynamic range. So this allows to emphasize the details in regions of the image that are important while making the less important regions less dominant. So piecewise stretching can be accomplished by defining a threshold value that separates the image into regions, one with low intensity values and then another one with high intensity values. A stretching function is applied to the low intensity regions while the high intensity region remains unchanged. So this can be done by using a linear or nonlinear functions, or by using a combination of different functions. A piecewise stretching can be useful for images with a dynamic range. We have such as remote sensing images, which are important to highlight the details in the shadow while preserving the details in the highlights. It can also be used to enhance the details in images that are difficult to interpret, such as images with shadows or low light conditions. So now we want to check on the practical part, whereby our original image is that one. So you can see the image it does not give the true appearance of uh, the actual appearance of the city. So if we want to make the image show details as they are, or the features as they are on Nairobi city, then we can come on the properties part again. Then we check on the RGB composite. So in this case, we are going to have the red, green, and the blue as the composite bands. So we can have red as band 3 in this case. So let's have it band 3. Then we have green. Green we can leave it to be band 2. And then we have the blue as band 1 in that case. So not we have the blue. Blue should be band 1. Yeah. So we are not going to show the alpha function because it's going to mess with the image. So if we apply this RGB composite that way, you can see uh, we can now have the true appearance of Nairobi city. So you can see the buildings are very visible. You can easily differentiate between vegetation and some bare lands. You can also differentiate between some of the buildings. We have the tall buildings, and we have the short. We also have the story buildings and the rest. So as you can see, this is an image that has been corrected for Nairobi city. So it can now show everything as it is. As you can see, even if you are to make a report on this, you can check on the distribution of buildings and also distribution of we have the parks, which are these ones. Then you can see this region also has some trees. So this one is uh, part of Nairobi city in Kenya. So it's now the true appearance. So if you are to keep on checking on the image, you can easily adjust the features, and you can have different details here. For example, if we can have let's check on the histogram in this case after adjusting the bands, because we are now working with the red as band 3, and then we have green as band 2, then we have the blue as band 1. So before we adjust the histogram, assuming we display the alpha, let's see the effect. It's going to, you can see the image has disappeared. So because we are supposed to use the RGB composite bands in this case, you can also adjust the standard deviation. You can use maximum to maximum, minimum to maximum. You can use histogram equalization, like we talked about it. We also have histogram specification, percent clip. So let's try to use the histogram equalize. So when we make the applications, you can see how our image looks like. You can see it's very different from the other one. Yeah. And then when you check on our Instagram, in this case, you can see histogram has been equalized. Yeah. So if we also come on the maximum and minimum, so this one is going to adjust the colors so that we have the darkest part appearing to be darker, and then we have the brightest part can easily be seen. As you can see, we have these regions, the white spots. So these ones are the regions whereby the image was taken when there was a very high lighting in those regions. So that one is about the maximum and the minimum stretching type of the histogram equalization. You also come on the histogram specification. In this case, when you check on the histogram, in our case, it's appearing to be straight, something like a diagonal like structure. And when you apply it on the image, you can see the, okay, let me check. That was a histogram specification. When you apply it, you can see our image has disappeared. So who can tell us the reason why the image has disappeared in this case? Yes, please. Why has our image disappeared in this case after having the histogram specification? But because when we come to minimum and maximum stretching type, you can see our image will be visible. But when we stretch it in a specification type, our image has disappeared. Okay. So when you check on the histogram, you can see yes, it's close to flattened, but you can see we have not made the specifications. So so when you come to display background value, you can assign the red value. Maybe we can give it 3. We can also give it that one 2. Then we give the blue value to be 1. And then we apply it. Okay. So, okay. Something is happening. Okay, there is something wrong. Let's go to percentage clip. So when you go to the percentage clip of RGB composite, you can see the effect it's going to have on the image. The image appears to be now more brighter, to be brighter, and then you can easily tell between the areas that have a lot of buildings and the areas with a good amount of vegetation. Like we have this one. This one is one of the parks that is inside Nairobi city, uh, the Uhuru Park. Then you also have these ones. Then these are the buildings. So you can see the image is very, very, very clear, and you can easily tell the difference between the buildings. You can see the highways. So these are the roads. You can also see some of the bare lands here. So that one is on percentage clip. So you can also adjust the percentage. We have the maximum to B2 and then in this case to B2. So if you adjust this one, it's going to also have the effect on the image. When we go to the sigmoid part, you see the effect it also has on the image. It's almost appearing to be like the first one. So all this is about yeah, it's about radiometric enhancement. That is, you are simply playing with the contrast, stretching, histogram equalization to give different interpretation of the image. It means you can easily tell when the how the city appears at night, how the city appears during the day, and also during very early in the morning. So all this about radiometric enhancement. So our original image is supposed to be this one. Okay, you are supposed to use maybe histogram equalization. Yeah, that one. So that is the appearance of Nairobi city. You can also use the histogram the percent clip. This one will also produce a very clear image, as you can see. It's something like a true image of Nairobi, such as it appears during a sunny day. So that was about radiometric enhancements in digital image processing. Maybe I can take one or two questions.
Thank you, Colin sir. Dear participants, am I audible? Hello.
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Yeah. I request dear participants, if you have any queries, any questions, kindly ask to Colin sir. Please. You can ask your question through chat box also. Colin sir, there are some questions in chat box. Please
Okay,
focus a
let me check.
light on the please.
Okay, someone is asking how we can convert drone and camera photos into a multi-band image. So this one was our original image, assuming this one was a drone image or a camera image or a camera photo. So you will convert into a multi-band image by coming on this section. You click on properties and then you check on we have so these are the different bands you can choose to adjust. We have band 1, band 2, band 3, band 4 and band 5. So you just assign the bands you like. For example, if we have band 1, we can assign red color as band 1. You can also assign green color as uh, band 4, The blue color as also as band, let's have it at band 6. But you can see the way you adjust your bands has a very uh, great effect on your image. Assuming we make now the applications here, we can apply it that way. So you can see uh, our image has been affected. So it's not going to give a true appearance, although it also means something in this case. Yeah, you can easily see the buildings are appearing to be something like a pink. Then we have the vegetation and the bare lands are also appearing to be green. So for you to get a true image of a true appearance of a place, you have to assign a red color to be band 3, and then a green color to be band 2, and then the blue color to be band 1 in that case. So it has to come in the ratio of 3 to 1. Yeah, in this case you can apply it that way, and you see it's giving a true appearance of the city the way it should look like. So that is it. Thank you very much. I don't know whether your question has been answered. Hari Kumar is your question, and not Hari, but who is Abdul Kafo. Is your question answered?
Yes, sir. All the participants have appreciated your deliberations.
Thank you very much, Hari Kumar. Thank you, Tanwar, and also thank you, everyone. Thank you very much for your time. If there is no question, then I can return back to the MC of the day. Thank you very much.
Thank you, Kolinji. Dear participants, it's time to extend vote of thanks. And I invite one of my colleagues and very versatile personality, Pratiksha Mohite Madam, to extend the vote of thanks. Mohite Madam.
Yes, sir. Uh, Good evening to all. I feel incredibly honored to have been allowed to extend a vote of thanks on this digital image processing workshop. On the behalf of the Department of Geography, Artlesapre Pitre College, Devruk, India, I would like to extend my gratitude to our special guest, Mr. Kulin sir from Kenya. Thank you, sir, to take out time from your busy schedule and to grace the event. Thank you for all your guidance and thank you all the participants for the presence. Thank you, sir.
Kolinji, once again, thank you, Indian thank you to you. Thank you.